So in this video I'll be showing you how to create a sound system for your car, so an engine sound system without gears for your car game that will have a starting sound, running sound and reverse sound. So let's see how it sounds. So we start the engine and we go forward. Okay, we leave the gas, we press the gas again. Now we stop it, we stop the car and we go reverse. And now that's the reverse sound. So forward with a RevLimiter, we stop, and we can also go reverse. So yeah, that's it. Okay, so first thing we want to do is to create an audio source for our engine. To do that, we go to our car and we create a new empty object, which we will call running sound. We put that around the engine, or place close to it. And we also add an audio source to it. Now we duplicate that so that we have our idle sound as well. And now we want to put our audio clips to our sources. So the running sound should go to our audio for running sound, and our idle should go to our idle. We also want to make sure that our sounds are looping. So we need to click this loop here and our running sound to loop as well. Okay, so now what we do is create a new script in our car, which we will call engine audio. Okay, wait, you can't see the script at all. Oops. Yep, so here's the script for now. And now we can open it. Okay, so now we want to reference our two audio files, sources. So we go to our Unity script and call a public audio source, which we will call running sound. We also want to have a max volume, so we will have a float that we will call running max sound, max volume. And since we also want to have a new we want to change the pitch of the engine as well. We want to have a running max pitch. And we do that exact same thing for our idle as well. Let me change the names a little bit. Okay. Okay, so we do that for our idle as well. We just change the names. Idle sound, idle running. Alright, so what we want to do now is make sure that whenever our car is actually moving forward and the gas pedal is pressing, that we actually produce a sound. So to do that, we also want to reference our car controller. So we will reference it here. And we will also get this from the get component script in Unity. So when starts, it gets the car controller. Okay. So now we want to actually get the speed of the vehicle and how much gas pedal is pressing it. So before we do anything with the audio, we want to go to our car controller and get the actual speed of the vehicle. Sorry, not the speed of the vehicle, but actually the speed of the wheels that are spinning. Since we don't have a gear system yet, we will get the speed of the wheels and we will convert it to engine sound. And to do that, we go to our car controller and we go to our speed variable, and we change it that instead that we use the velocity, we use the wheel RPM times its radius, times its circumference, so that we get the actual wheel speed. Okay, so to do that, we call the colliders of our wheels. So we get our rear right wheel, we can use any wheel or the average of them, times the RPM, times the radius of the wheels, so that's radius, times 2 times pi, which is the formula for the circumference. And since we don't want this to be a huge number, we will divide it by 10. Okay, so now that we have our speed, we also want to know the max speed of the vehicle. So we will create a new variable in our car, which we will call public float max speed. And we will also limit the car's speed to that speed. So if the speed is higher than our actual speed, than our actual max speed, then we will not apply any motor torque. So we go to our apply motor, and we say if the speed is higher than max speed, if it's lower than our max speed, then we can actually apply some motor torque. If it's not, then the motor torque is 0. So we take this and we actually say that's 0. Okay. And now we want to also create a function that actually gives the ratio of the gas pedal times the speed divided by our max speed, so that we get a 0 to 1 value of how much engine are we using. All right, so we create a new public function which will return float, and it will be called the get speed ratio. And so we want to actually get our gas input as well. So that's going to be the clamp of the gas pedal from 0.5 to 1. And we're going to also give it our gas input. So that actually limits our gas to be from 0.5 to 1. So it's actually half of the gas input. And now we want to actually return our speed times our gas divided by our max speed. Perfect. So now we go back to our audio source and we actually change the sound of the audio to match our speed. Okay, so now we want to actually check what the ratio is. So we create a new float, which we will call speed ratio. And now we want to reference that speed ratio. So we check that our car controller is actually there. And if it is, the speed ratio will be equal to the speed that we have. So the car controller dot get speed ratio. Perfect. So now we actually change the volume of the sounds. So we will set the idle sound dot volume to be equal to the in between of 0.1 F and our actual idle max sound. And the between value will be our actual speed. So that's that. Also, we want to have our running sound to be equal to our speed times our gas, that's basically our speed ratio. And if we redline our car, so we are at maximum engine speed, to actually move the pitch back and forth so that it actually sounds like it's cutting off power and it's giving power, it's cutting off power and it's giving power as well, like a regular RevLimiter will do. So to do that, we actually want to change our running sound volume to be equal to the in-between of 0.3 F and our max running sound. And the sound will be also equal to our speed ratio. And now the pitch will be equal to our in-between again of our running pitch, of our 0.3 F again, and our running max pitch. And that's going to be equal to our speed ratio times the, times the actual speed ratio. And let's try that, and next we'll do the RevLimiter. Let's see if that works. Let's set up everything. Running sound, idle sound, and also we want to set our max volume to 1, our max pitch to 2 again. Also, we don't need the max pitch for idle since we are not going to change the idle pitch, so that's going to delete it. And let's see if it works. Okay, let's see if it works now. We will put the max speed here to 50. And so let's check if it works. Okay, so we can definitely hear the engine sound right now. And if we press the gas, we can actually hear the engine revving. but the problem here is that if you can hear, there is this cracking noise when the car is reaching its top speed. Okay, and obviously we don't want that. So to fix that, we want to clamp the sound so when it cuts off the engine power, it basically emulates how a rev limiter works, and it doesn't just cut off the actual sound of the engine. Alright, so to do that, we need to go back to our car controller and change the way we use the speed. So we create a new variable, which we will call speed clamped. So float speed clamped, and we go back to our update and we set this speed clamp variable to be equal to the mathf.lerp.speedclamp to actual value of our speed, so to this, so speed, and time.delta time, which means how fast the frame took. And we actually use that variable instead of our speed for our get speed ratio. Okay, we can also go to our engine audio, and instead of changing immediately the pitch, we can change it to its actual self, so it's also dampened. So we create a new mathf.lerp. We call it, the first variable will be our running sound.pitch. Our second will be our actual pitch that we want to achieve. And finally, we will also use our time.delta time. And let's see if this works. Okay, let's see. So we press the gas. It's accelerating. And it's reaching a limit where once you reach this limit, it doesn't go any further. Sorry, the pitch doesn't change any further, so it doesn't create a weird sound. So now what we want to do is also create the rev limiter sound. To do that, we go back to our engine audio, and we create three variables, which we will call rev limiter max volume, frequency. Yeah, I think that's two. And let's see what else we will create. And at what variable the rev limiter engages. So that's going to be public float limiter sound, which we will set to 1f for now. Float limiter frequency, the frequency that it oscillates, which we will set to 3f for now. And the public float limiter engage, which is going to be 0.8f, which means that if our speed ratio is 0.8f and higher, the rev limiter will engage. Sorry, if the ratio is higher than 0.8f, than our limiter engage, which let's fix this typo, then our rev limiter will be, so we also need to have a rev limiter float as well. Okay, so our rev limiter will be equal to our mathf.sine, which will be our which is basically the sine function that oscillates up and down like a sine wave. And inside there we will put our time times time times our limiter frequency times plus 1, so that it doesn't have a negative and positive value. And we multiply that by our limiter sound, so our max sound, and we also multiply that by our speed ratio minus our actual limiter engage value, so that it starts from 0 and goes to, in this case, 0.2. Okay, and now we add this to our running sound pitch, so rev limiter, and let's see how it sounds. Oh, okay, let's see. Yeah, that doesn't sound right. We want to change this here to, instead of going to our new running sound, we want this to go to our to the address we want to reach. So we're gonna add this to our second variable of our lerp function, and let's see how that sounds. Okay, so that has a actual oscillation in the sound. So that sounds a lot more than a RevLimiter, so we can actually we can also increase the pitch if we want to. So the frequency we will add this to 30, and let's change this to not 30, like 10, and let's set the limiter to 3. Let's see how that sounds. Okay, let's see. Okay, that sounds a lot more like a RevLimiter to me, although it does sound kinda weird due to the dampening, but it's cool. So now, next thing we want to do is actually create a starting sound. So if our car hasn't started yet, we want it to start and then to actually run the engine. To do that, we go to our car controller and we create a new bool that we will call is engine running. But because we want it to have 3 states, the not running state, the starting state, and the running state, we will set this as int, as an integer. And we will apply torque only if the engine is running. So we go to our apply torque if engine running is higher than 1, so that's 2 and up. So that's the running state. We actually have our engine is running. And so we also want to create a function in our audio, which we will call, sorry, not a function, a coroutine, so enumerator, start engine. Which will set the running state of the engine, plus it will also start the engine. So we will go to our enumerator and we start playing the starting sound. So we need to have a new reference to our starting sound. Okay, and so we start the starting sound. Well, it also starts. Dot play. That's not a start. Okay. We set the engine, our car controller engine state, to 1, which is starting. We wait 0.6 seconds. Yield return new wait for seconds. So now we also want to have a variable here to check if our engine is running as well, which we will set to false. So if engine is running, we actually change the sounds. If it's not, our idle sound, will be equal to 0, and our running sound will also be equal to 0. And we enable now our is running variable bool, so we set that to true. We also now wait around 0.4 seconds, so that we set our engine state to running. So car controller dot is engine running to okay. So now we also want a way to start the engine. So the way I'm gonna do it is check if the gas pedal, if the gas input is higher, if the user is pressing the gas pedal. So if the absolute value of the gas input is equal to, is higher than 0, we want to get the component engine audio and actually play the sound. Start the engine. So start the engine. So that's a coroutine. So we start that with start coroutine function. Okay, but we also want this to only launch once. So we want to check that the is engine running is false, and then is not equal to 0. Let's see how that sounds. So we go back to Unity. we go to our starting sound and we create a new sound. So here, sorry, I forgot to name this the running sound. So here we go to our audio source and we set this to our starting sound. And we also set the name to starting sound. We reference that to our script. And let's see how that works. I hope that works. Okay, that did not work. So that did not work because we have the starting sound to play on awake. So we set that to 0. We also need to set all the values of our all our volumes to 0 when we start. So like that. And let's see now if it works. Okay, so let's see if that works now. Okay, when I press start, it doesn't do anything. That's because Okay, that's because in our car controller, when we actually check if the engine is running, we actually want to check that it's not running and not that it is running. So let's see now. Okay. Yes, it's starting, and now the engine is running. And when I leave the gas pedal, it stops revving. Yeah, that's good. So we also need to create the reverse, but that's going to be easy. So let's try that as well. So for the reverse, we go to our engine audio. We do the exact same thing we did for our running sound, but we actually change it to reverse. So okay, so we go here and we want to check whether our car is moving forward or if it's going in the reverse. So we will create a new float. Sorry, a new float, which we will check if the car is going forward, backward. So to do that, we're gonna create a new variable to check if the wheels are moving forward, backwards. So here that we set our speed ratio, we're gonna actually get the absolute value of that. And we're gonna have a variable, a float, which will be speed sign. So if it's 1 or -1. So speed sign will be equal to the sign of our variable. Okay, so now if the speed sign is bigger than 0, so if is there an error here? So it's because we haven't initiated. Yep. So if that's higher than 0, we're gonna set the running volume to 1. Sorry, not 1, but we're gonna set the running volume, but the reverse volume will be equal to 0. And we do the exact opposite thing of that for our reverse. So here we copy paste that here, and instead of reverse sound being 0, we're gonna set the running sound, reverse sound, reverse sound, reverse sound again, reverse max volume, reverse sound, and sorry, not reverse sound, so reverse max speeds, sorry. Okay, and that should work. Yeah. So let's say we set up the car controller again to have the reverse max volume to be around 0.2 and the max speeds to be 1, and we also create a new sound which will contain a reverse volume, a reverse sound. Okay, so we put our engine reverse here and we reference it to our script, and let's see if that works. Okay, that's not working. That's probably because we also want this to be equal to 0 immediately. So let's see if it works. Okay, so the engine starts, we go forward. Perfect. We brake, we go backward, and it sounds weird. It sounds really weird. So let's see why that is. Okay, so there are two problems with our script. First is that our car controller here, when it checks for speed, it tries to check for positive value, but we want absolute value. So here, instead of speed, we want the absolute value of that. So the absolute value, of speed. We also want the absolute value of our gas input. So this should be our absolute value. Perfect. So let's see how that works now. So, okay, let's set that to 0.2 and let's see if that works. Okay, so we start the car, we go backwards, and it still sounds weird. Okay. Okay, and final thing we want to change is to set the actual reverse volume to 0 instead of 0.3, so that it actually sounds like we're reversing and we don't start the engine immediately. So we go back to our car and let's see if everything is set up correctly. Max speed should be 50, and let's set this to 0.2. Okay, that's perfect. Let's see. So the car starts now, and we reverse. Perfect. We brake, and we accelerate. Perfect. So let's actually change this a little tiny bit so that the reverse sounds a little bit better. So that should be around 0.35. And instead of the reverse speeds being 0.3 to 0.2, let's see how that sounds now. So we start the engine, we go forward, which is perfect. We brake, and we go backwards. Perfect. So yeah, that's the sound system. I hope you liked it, and thanks for watching. In the next episode, I'll be doing a gear system for the car, so revving sounds and gears, clutches, etc. So yeah, stay tuned for that video, and thanks for watching.